So, guys, long time no see. I hope you guys enjoy the great winter break or the Christmas vacation. So, today we're gonna do something related to the integrals, which is the second most important part in the calculus. So, integral basically means it's antiderivative and it's very useful in our daily life, like physics and chemistry or biology or architecture. They're really important. All right, let's see the question. So let uppercase g of x equals to definite growth from 0 to x of f of t dt. The graph of f on the interval, closed interval 0 to 12 is shown below. Determine the intervals on which g of x is increasing. Justify your answer. So g of x is antiderivative of f of t. So if g of x is increasing, we basically find where the where the where the derivative of g of x is positive or is greater than 0. So it's 0 to 4, it's positive, and 8 to 12, it's a positive. So we're gonna say from 0 to 4 union 8 to 12. Alright, when we determine the intervals on which g of x is it's decreasing, justify your answer. So decreasing means g prime of x, which is f of t, it's less than 0, so it's from 4 to 8. Find the x coordinate where g of x has a local min or max. Justify your answer. So g of x as a local min or max basically means f of t has a 0 like 4 and 8. So we make a sign chart here. 4 and 8 because it's 2, it's a as a critical numbers. So we determine the sign before the 4, so it's positive. And between 4 and 8, it's negative. And after 8, it's positive. So 4 is positive here, so positive means it's increasing. Negative it's decreasing, and 8 is positive. So here at 4 we got a max, and at x equals to 8 we got a min, because at which point the function it changes its sign. I mean the derivative of the function of g of x, it changes its sign. So it means there's a positive, there's a max or min. So find x coordinate of point of inflection of g of x. So point of inflection means double g prime of x equals to 0. So it's f prime of t equals 0. So f prime of t is here at 2, at 6, and at 10. So at 2, 6, and 10, there's a point of inflection. Let's see, determine the intervals where g of x is concave up or concave down. So we're going to determine on which interval the f prime of the f of x, it's a derivative of g of x. So from 0 to 2, it's increasing because the slope is greater than 0. So we're going to make a sign chart here. 2, 6, and 10. So before 2, actually more precisely, it's from 0 to 2, it's positive. And 2 to 6, obviously the slope, it's less than 0, so it's negative. and from 6 to 10 it's obviously positive again, and after 10 to 12 it's negative again. So from a 0 to 2 it's concave up, 2 to 6 concave down, concave up, concave down. So from 0 to 2 union, 6 to 10 is concave up, and from 2 to 6 union, 10 to 12 is concave down. Right. This is actually an introduction to integrals, so you guys probably will understand some of the concepts, or more actually it's not about, it's just introductory of the integrals. It basically means the antiderivative. So I hope you guys probably just get some of it, and we're gonna do something more next video. Thank you.